What friction effects impact actual heat engine efficiency? Imagine trying to push a heavy box across a rough floor. It takes extra effort, right? That extra effort is similar to what friction does inside a heat engine. It fights against moving parts and wastes energy. When parts like pistons, bearings, and valves slide or roll, they create friction. This friction turns some of the engine's useful work into heat that doesn't help move the vehicle or generate power. So instead of all the heat energy turning into work, some is lost just because of friction. Mechanical friction losses happen when parts rub against each other. For example, piston rings slide inside cylinders, and crankshaft bearings spin under load. These contacts generate heat and wear, which means the engine needs more energy to keep moving. That extra energy used to overcome friction reduces the net work the engine can do. Think of it like trying to push a sled over snow. You need more effort to get it moving because of the resistance. Friction also impacts the efficiency of different types of heat engines like the Otto cycle used in gasoline engines or the diesel cycle in trucks. In these engines, pistons move up and down, and valves open and close, all of which involve friction. This friction reduces the amount of useful work produced, lowering the overall efficiency. Another effect of friction is heat generation. When parts rub against each other, they heat up. This internal heat increases the temperature inside the engine, but it doesn't help produce more power. Instead, it makes the engine hotter, which means more energy is needed to cool it down. Cooling systems like radiators and fans work harder, adding to energy losses. In real engines, processes happen in finite time, so they are not perfectly reversible. Friction is one of the main sources of irreversibility, which means the engine can't reach the ideal efficiency predicted by theoretical models like the Carnot cycle. Friction always causes some energy to be lost, so actual engines are less efficient than the ideal ones. To improve efficiency, engineers work hard to reduce friction. They use better lubricants, smoother materials, and tighter manufacturing tolerances. These improvements help parts slide more easily, saving energy and making engines more powerful and efficient. Friction isn't the only loss in an engine. There are also heat losses through exhaust gases, cooling systems, incomplete fuel combustion, and gas pumping. But friction is unique because it directly consumes the mechanical work the engine produces. It acts like a hidden drain on power, making it harder for engines to reach their maximum potential. In summary, friction impacts actual heat engine efficiency by using up part of the work that the engine produces. It turns useful energy into internal heat and causes extra work to overcome resistance. This effect is why real engines can't reach the perfect efficiencies shown in simple thermodynamics models. Reducing friction is a key focus in mechanical engineering to get more power from every drop of fuel or heat input.